We can't hear you. You are on mute.
Hello, hello.
Yep.
Yep. Okay. Today we're going to talk about these 5 topics. So AWS CLI, probably you've used some of the commands in the AWS CLI to do the exercises. We're going through some main commands, how to find some help, but not really in detail for every command because actually almost every service is reachable via the AWS CLI. Next one will be AWS Identity and Access Management, IAM. Next one, S3, and object storage. Next one will be RDS, Relational Database Service, obviously for relational databases. And Kiko will present Infra as code, IEC, which is a very important concept in the Devops area. It helps us to reduce the feedback cycle and to automate things, mainly keeping the infra in a state that we can manage better changes. And yeah, I think that's it. I won't talk much. Let's get to the content. So for AWS CLI, as part of the pre-class exercise, probably all of you installed the AWS CLI. And you, well, just a note on that, there's a new version. If you want to upgrade, help yourself. It doesn't depend on Python. You can just install as a standalone package. But yeah, there are some other features, but that's it. So considering that all of you have this installed, the CLI will serve as an interface for you to interact with the AWS APIs. So for every service that you have in AWS, like EC2, IAM, S3, RDS, and so on, you have an API that is usually RESTful HTTP API. And the AWS CLI serves as a way of calling these APIs, mainly via command line, which enables us to automate things easier. We could just call the AWS APIs if we wanted to. It's possible to automate stuff doing just these API calls, but the authentication part is a little bit tricky. So the AWS CLI help us to abstract this complexity in this. So as via console, when you interact with AWS for any service, like this is S3. When you open S3 and it does this loading buckets, it's actually doing that LS, that list buckets action. In fact, it's calling an API. So these are just different ways of calling same APIs, which is the way AWS did the reuse in this case. That's what we actually do in software, right? So for accessing, the same way you needed an user or a role to access services in the console, you needed to authenticate to reach the S3 service, EC2 service. You need to configure the CLI to reach the services. Have you done this configuration? Can I have a thumbs up? Did everybody do this configuration already? No? Karini? No? Okay, that's all right. Denise? That's all right. So quickly, when you configure the CLI, you need basically to pass access key and a secret key. So the CLI can use this user or these credentials to reach the services. The easier way to do it is doing AWS configure. Profile is optional, but it's good to have. But when you do AWS configure, it will ask you for this information. So it's pretty much straightforward. If you have the CLI installed, AWS configure, it will ask for access key, then secret, region is not optional, output format as well. So it's configuring your environment. So you can do something like AWS S3 LS. That's basically it. Profiles here come as a way of organizing the users you configured in the AWS CLI. So to check which profiles you already have, you could just list them using configure list profiles. And for configuring a new one, you can pass as in the documentation, just -- profile and a new name here. It will store the profile. Why is that important? Because in this case, I ran AWS S3 LS and that worked, but it's using some of the profiles. It's using a default profile. If I wanted to use this Kaka profile that I created, I could just pass for any AWS CLI command the -- profile and the name of the profile, and it will reuse this profile that I configured. So in this case, it will fail, probably. It's all wrong. I configured the region ASD. This region doesn't exist, but that's just an example. So you can manage these profiles. You can pass a different profile for each AWS command if you want to. All right. So the next thing about profiles is that instead
just a quick question, because I'm running this AWS configure as well. And how do I know if I've done that or not? Because I'm not sure now.
If you do, I won't do it here, but a way of checking your credentials is just coming here and doing a cat on this path here, which is the default path for AWS credentials. So your user space dot AWS / credentials. This is a file. So if you list this file, it will list the credentials in plain text.
Okay. Can you just copy and paste this on the chat? So I can just copy from there.
Yeah.
Or maybe on the channel, sorry.
Where is it? I lost my...
Yeah, but maybe in the channel. The Slack channel.
I can send it on the channel.
Yeah.
Yes. Yeah. Okay.
Kyle or Kiko can send that to you, but I sent in the chat. One more thing, guys. I'll just go forward. If you have a question, you can just mute yourself and ask it. Or if you prefer, you can write the question in the chat. And after finishing each subject, I'll check the chat, or Kyle can check the chat, and we answer them.
Okay, thanks.
Welcome. So another way to switch between profiles is using the environment variable AWS_profile. So in this case here, if I do AWS S3 LS, it will work again because it has my default profile configured. It's okay. But let's suppose I'm using the one that I just created, Kaka, which is a bad configuration, right? If I set this environment variable for this session in my terminal, any AWS CLI commands will use it. So if you run AWS S3LS again, you can see it's the same result as passing -- profile. So it's one way of switching between credentials in AWS. Right? Another way that you probably know is setting these environment variables, AWS access key ID, AWS secret access key, and a session token optionally. Between these different ways of setting credentials, there is a hierarchy. So the CLI will look into in one place first, then it go to check others. For example, these AWS access key, ID and secret, they have preference over the other ways of setting the profiles. If it doesn't find the key and access key here, so it's not set, if it's not set, it will try to check the profile, if I'm not mistaken, and so on. Then try to check the instance role, for example, that you already know you've done it for the EC2 exercises. So it has a hierarchy. And how do I know, for example, how do I know which user is actually, which credential I'm using here to check this, to run this command, S3LS? Does anybody know?
You can use echo.
Echo what?
And the expression, the same expression you put that value.
You mean for checking the environment variable, you mean, right?
Yeah.
Okay, but when just running AWS S3LS like this.
Okay.
Because the CLI will be looking into different places to set the credentials and grab valid tokens in order to do the API calls, right? So one way to do it is using a service called STS. I think it's Secure Token Service. Yeah, it stands for something like this. And STS service has get caller identity, exactly. With get caller identity, if this user has permission to call this service, of course, you can see who is running this command when using the CLI. So it's possible to see here that I have an user called Dennis Mac, which is running this S3LS command. So yeah, that's it. We'll get into more details in IAM in a second and how these permissions actually work. But for the CLI, one last thing that I'd like to tell you is you'll need help probably because there are hundreds of commands, I'd say. For example, if I type AWS help here, and you can scroll down, you'll see just the services available. And we have 156, something like that. These are the commands only. But if you dig into one of these, sorry, these are only the services. If you dig in one of the services, like S3, for example, and you an S3 help, then you see contextualized just the help for the S3 service. And this goes on. For example, I don't know how CP works. I don't know what CP does. I can type AWS S3 CP help. It will detail for me just the CP command. So as you can see, there's a lot of documentation. And there are many commands. So always check this help because it's really useful. If not, you can check AWS CLI documentation online, which is pretty much HTML version of the same help. Where is it? I think it's, yeah, it's here. So here I could type S3 copy. Well, it seems it's looking the database. Well, believe me, this information is here. S3, there you go. You can check S3 here. Then we have the cp commands. There you go, cp commands, and you have the same information on the web. So, going back to the material, okay, help. AWS S3LS, we already know it. So that's basically it for the CLI. We talked about just the CLI. The main takeaways for this are you need to have it installed. You need to have it configured with a valid identity, which is a user in this case for now. And this user needs access to some AWS service. If this user has access to that service, you can perform that command using the AWS CLI. If it doesn't have access, it will throw an access denied error, which leads us to the next topic, which is IAM. So about AWS CLI, is everything all right? Do you have any question? No?
I got one question.
Yep.
You mentioned that AWS CLI is good for kind of like our automation tasks. So what type of automation tasks do you mean exactly? Building infrastructure or kind of like your BAU tasks when working in an environment?
Yeah, I'll give you a practical example. For example, today I was retrieving a database password in order to pass it to the CloudFormation template, which is part of the Infra as code, is Infra as code 2 that AWS has. And for retrieving this information, I had SH script. And in this SH script, I was retrieving this value, which is in a service called System Manager in AWS, just to get this value, retrieve it, and pass it as a parameter to the CloudFormation. This is part of my script, and I didn't want to hard code it, for example, because it's the database password, right? And at the same time, I'd like to use some AWS service that helping me with this automation. So putting this call inside my SH script in a way that I can just call this SH script on a pipeline, for example, is a way of automating this token or secret retrieval. In a similar way, you can automate packaging, for example, for S3. You compile an application, you put all dependencies on a folder, you run a zip recursively, and call AWS S3 copy to cop from your local folder to an S3 bucket, for example. This is another example.
Yeah, I gotcha.
So AWS Identity and Access Management. What is it? It's the service that AWS uses for almost any other service. I think for all services in terms of authentication and authorization, it will use IAM in the end. It's a way of describing entities that we'll see in a minute what they are, and permissions, and even for delegating authentication or authorization for external systems. For example, if you're doing federation, let's suppose you have a Windows Active Directory and you want to authenticate your users in your Active Directory. You don't want to create AWS users all over again. You need to configure the federation in IAM service, for example. So in the end, it is the service that you use for authentication and authorization. And it has these main 4 pillars, as I called it, which are the things that are really important in the service for this introduction. We have users, groups, roles, and policies. Now, Chris, for you, what do you think users are? What they are for?
If you just want to I guess just if you want to add users, I guess, like I'm sorry, enabling some people to do some yeah, some things.
Yeah. And what do you do with an user in any system? What's the main goal of a user in terms of authentication? Which is
okay. It's like maybe you mean like you want them to be able to, you want to set settings. Is that what you mean? Like like
no, when the user go there and type the username and the password, what's the first thing that we do with this information?
I'm not sure. I don't know.
Right. Anyone else?
I think you mean logging.
Yeah.
The system go and try to check the credential and make sure if that credential it's valid. It's allowed to get access.
And this process has a name, which is?
You need to set permissions.
Authentication.
Authentication, exactly. This is authentication, and we'll start to differentiate what is authentication from authorization in a second. After authenticating the user, let's suppose I got the password, I checked in my database, plain text, very secure, and I checked that the user is valid. How do I know if that user can perform that action? Let's say the user wants to delete the database, I don't know. He wants to delete the organization. He wants to format and delete everything because he's angry. How do we check and how is it called?
I should give permission to user, and then you can compare the credentials that you have with the settings that you set up for the user.
Yeah, that's pretty much it. After authenticating the user, we know that the user who he is, in fact, right? We know the identity of that user, but we don't know exactly what he can do in the system. So checking what the user can do in terms of permissions is called authorization. And usually these two concepts walk together, authentication and authorization. IAM, these 3 letters, IAM, they're not specific in AWS. There are IAM solutions in the market, identity and access management, that basically works with this authentication and authorization flows. So for our 4 pillars here, this is a tricky question, but yeah. Which ones of these 4 pillars you think is for authentication and which ones for authorization? Anyone?
The first one, the users, is for authentication. Groups, I'm not sure. And authorization is for roles and policies.
I think it's like the users and groups are for authorization, and the last 2 is authorization. The first one's authentication.
Well, that was a tricky one. In AWS, it's a little bit mixed. One thing that we can say for sure is that AWS IAM policies are all about authorization. Then going to the left, IAM roles can serve for, they are mainly for authorization as well. But after you fetch a role, what we call assume role, we'll see it in a minute, wait a little bit. After you assume a role, you become that role. So it can act as an identity as well. IAM groups are just a way of grouping users, IAM users, but groups and users, even single users, may have policies attached to it. So a user in AWS, it is an identity. It's used for authentication, but it can have policies attached directly. Groups, you can have, for example, this is the IAM service. I have 7 users here. In the groups, you can see I have a group admin, another group developers. In this group developers, I have Dennis Mac and Dennis. And here I can attach policies, which are the permissions for this group, right? If I go to roles, same thing, we can attach permissions to roles. So basically for any of these 3 here, we can attach policies. And there's evaluation hierarchy. There is evaluation flow. First, it will check one thing, then the next thing, then the next thing, until it finds a deny, something that blocks it, and it's final, or it will just keep evaluating. Can it do it? Can Dennis create EC2 instance? Then it will check on the high level, then it will start to dive, check in the lower levels. If nothing blocks Dennis from creating EC2 instance, it will be a grant in the end. So scrolling down a little bit, these basically are the users. We talked about groups, just a group of users. Roles, we'll get to this evaluation logic in a minute. Don't worry too much about it right now. I'd like to stop here for a minute in roles. So a role is it is basically how can I say, it's an entity in AWS that you can attach policies in the same way, but they are more flexible in terms of identity, because as you did in the EC2 exercise, do you remember that you added what's called instance role, instance profile role. And you needed to add it in order for the EC2 instance to access S3, right? And in the exercise, we were asking for AWS S3 LS. So a role can be assumed, or a role is like a hat. A role can be assumed by not only users, but also services. So when you created the instance role for EC2, the EC2 service was basically put on wearing the hat of this role and assuming the permissions that that role had. So that's the main difference for roles. They're assumable. So there's a place, a special place where you say who can assume a role. And you can see via console here in the trust relationships, where I have these trusted entities, and I have the account X, which is my current account. So what's saying here is this role admin that I have is assumable for any user under this account X. That's basically it. I could change it to say the principal, which is who is assuming it, is the EC2 service, for example. So what you did without knowing when you created instance role, you created a role where the EC2 instance was the entity with permissions to assume it, just to assume it. After the instance assumed it, it got the permissions described in the tab permissions here. So that was the flow that you did. So what's the actual permission? What are the policies? What's this thing that we keep attaching to everything, right? So an overview of a policy is this picture here. It's basically describing an effect. So probably it's easier if I get an example here, simple one. It's basically describing an effect, which is allow or deny of an action. And here you have all kinds of AWS services, S3 list buckets, EC2 creating instance, anything usually that you can do via console, you can configure here as a permission. And this effect on this action for this resource. That's the simplest way to read a permission. What is a policy? A group of permissions. So here I have a policy. Each object here in this JSON is a permission. So policies are described just in JSON, right? Not in YAML. And the main structure is what you're doing, which is the action. If you're allowing or denying, which is the effect, on what you're acting on. So if you have an action here, S3 something, probably you're acting on a bucket or an object in S3. Doesn't make sense to include a resource here like EC2 something, because a EC2 instance, for example, don't have an action list all my buckets. So these two are usually consistent. And the last thing is, which is not shown here in this example. Let me see if I grab it, which is the principle. I'd like to show you an example. Principal. Principal is the the last bit of the permission that wasn't answered. So we talked about what action, what permission, which permission, allow or deny, on what, but who has permissions to do it in the end. And this is the principal here. So the principal can be an AWS account, an IAM user, a federated user, a role, assumed role sessions, services, and so on. So that permission you created for EC2 to access S3 was basically allowing EC2 to assume the role. After it assumed the role, it gained permission to list buckets, if I'm not mistaken. List buckets, this is the action. Allow was the effect. Resource, I don't remember what did you do exactly, but it can be star, which is allowing for all resources, because it do allow wildcards, as you can see here. Even for actions or resources, you can use star, for example. And the principal. Sometimes we don't need to pass the principal, but I won't get to this detail right now. When you do what's called resource-based policies, which are policies attached to a resource directly, you don't need a principal because it's a policy that's valid for that resource as an object. Like, it's not a user that can do something. It's the object that's saying who can do something with itself. And this is the, I'll get to your questions. I think there is something in the chat, but just a minute. I won't go through it, but this is the valuation policy. So as you can see, just take a look here on the bottom. Don't worry much about this flow chart as a whole. Everything begins checking if there is any deny evaluation, because the way this works is checking several services, several layers, and looking for an explicit deny in at least one of them. If it finds a deny, it will deny in the end, right? So that's what's happening basically here. So it starts with a deny. So when you don't specify an explicit allow in AWS, in any service or layer, let's say, it's denied by default. So it starts with deny and it starts looking in the organization SCPs, which is the organizational level of policies. Then it will check resource-based policies, IAM permission boundaries, don't worry about that. Session policies, which are the permissions inherited by the role that you assumed, for example. And finally, the last bit here that you can see is checking the permission for the user. So what I showed here to you about user and the possibility to come here and just attach permissions, like this user, Dennis, has administrator access. But if any of these evaluation steps deny it first, this user then won't get administrator access. So probably on your daily activities, working as Devops and with AWS, you'll find a problem like that every second day or third day. You try to do something, you're trying to do an automation or something, someone is asking for help, saying that the access is denied, and you need to run this evaluation policy in your head and check step by step in this flow. So don't worry too much about this. There is the link for the documentation here below, and let us know if you have any question about that. Let me see how I am with time. Okay, let me, yeah.
Dennis, one question about that. There are some possibility to test this, like in firewall, for example, when you have many levels of the rules, you just put the IP address there, and the system firewall will check which policy that IP address are matching, and you can go further and dig that policy. In that case, there are some tools which I can do this type of troubleshooting.
That's a good question. I'll ask for help for Kiko and Kyle, but I don't know any.
I don't think there is.
Usually
you can check,
it's manual.
Yeah, you can check if it's being denied at some point through the CloudTrail. The CloudTrail will show that that request from that user has been denied, but you won't show that it has been denied in the policy name X, and so no, not at that level that you have on firewall devices.
It can take a while, I know. Sometimes it is denied and it is in specific permission boundaries, or it's your organization that blocked it. For example, a bank didn't do compliance checks for service, I don't know, RDS, let's say. So they can block it in the first step here. The first step is organizational SCPs, which are organizational policies. So they can say at this level that anything related to RDS is blocked. So you won't be even able to list RDS instances or create database for sure. No, any API in AWS going via console, via REST API, or via CLI will be blocked for you. So that's an example which the enterprises use a lot. For example, another example is denying any resource creation out of Sydney region because of data forensic policies. So we can hold your data in US, for example, so it's only Australia. So then they deny it on this organizational level. So anybody, it blocks for everybody, any EC2 instance creation on US EC1, for example.
Yeah, and it's good to know this workflow, because when you're troubleshooting, you need to go on each of those, let's say, layers and check if there is any deny on the action that you're trying to do. So it's important to know that when you're troubleshooting, because you can follow those steps to try to find where you're missing or where is the problem is.
Yeah, that's all right. Any question before we move on? There's, yeah, a quick section here before finishing IAM, then I'll go to S3. Any question at the moment? Is that right? Okay. Yep.
Dennis, I'm just wondering, so when you create a user, do you, so the best practice is to add him or her to the group and then attach the policy?
Right, that's a good question. I'd say it depends on the size of your company. Because there are other ways of managing this. If you're in a small or medium company, users might be enough, and controlling access via groups might be enough. But as employees come and go, you need to block these permissions because they could potentially access from home, for example, if you didn't configure well your organizational policies. They could do things out of work, for example. So the effort for maintaining this becomes harder and harder as the time goes by. So in big enterprises like banks, for example, telecom companies, any enterprise that has more than 100, I'd say, employees, or less than that, it depends on the maturity of the cloud guys. They use some kind of federation federation is basically reusing some authentication mechanism, external one, to validate an user in AWS or any other tool. So they use, for example, Windows Microsoft AD, Active Directory, to authenticate and to, in the end, map the roles and permissions that that user has. And this way, when an employee is fired, for example, they can just delete it, inactivate it in the AD, and it will lose all AWS access as well. And so the AD would be the source of truth for your identity and access management, because it's bad to have several tools where employees create a different user for each tool, right? How do you manage that? It's unmanageable as it grows. So usually these companies have AD, and you can use Teams, Microsoft Teams. You can do several, you can open websites. It's already authenticated for you. You can open AWS, you receive a role. And when the employee is not there, they just inactivate it or delete it, and all is gone.
It's basically just to make another point. Just basically is, if your company is already managing your users to another platform, for example, AT, as Danny said, or maybe Google Apps, like even the small companies will normally have some system to manage the users. So when they start having some work on AWS, they don't need to create new users. So they can just make a link from the users from your system and match with roles on AWS. That's why that's when you don't use.
Yeah, well, I'll show this one. It's not part of this.
In that case, you can still maintain the Active Directory users, for example, and just map the rules with that man base and gone. That's it.
In your Active Directory, you'll have groups related to these users. Then you need to map these groups to roles here, and the roles here will have the permissions.
So, because let's say one user can have can be in, say, one group, and he also has a role attached to him. Has there been any clash that say this group for the role for this group you can't access, say, S3 bucket or something, or billing, but for the user's role, actually he can actually access billing, if you know what I mean, like which role overrides? Is it the user's role or is the group's role?
That's the evaluation policy here. So if you assume the role, it will be in this layer here of the section policies. You've created a session with a temporary token and you're using that. So it's evaluated first. And if it has a principal and identity, like a user related to it, it will check afterwards. So there's an order for it. It will fail in the first deny that it finds.
Okay, yeah, understood.
Yeah, one thing that I think it's important to mention is that in order to use the permissions that are provided through a role, you need to assume the role. So if you're logging with the user Christina, you won't be able to execute tasks or actions that are allowed from the role unless you assume the role.
Yeah, and on that, a simple way to bring together what we talked about in AWS CLI with this assume role thing is this command here, for example. I can do a assume role here, but it will show my credentials. So probably I'd rather not. Let's see. I don't know. I already prepared for it. So I have this course dev 01 role that I created here. Let's do it quickly. I'm running out of time and there are 2 other subjects yet. Course dev 01. So what is that? What it allows? Anyone can say here for me? What is it allowing?
Amazon S3 read only.
Only. Yeah.
Okay, so any get anything or list anything action, it will allow in on any buckets that I have, right? Who can do it? Who can assume this role?
An account listed on this 2813 something.
Yeah, any user or identity in this account. So it's a pretty open trust relationship that I have here. I could restrict it further to be more secure. But for now, yeah, it's allowing any user in this account to assume this role. So that's what I'm gonna do. Who am I? I am in this account, right? I'm a user in this account and it's called Dennis Mac. If I run STS assume role and I say the role ARN is the course dev 01 role, I need to give it a session name. What it will return to me. Do you know what's this information?
Does it like a token?
Yeah, what else? You remember the environment variables that we set for
your AWS for
This is the username and password?
Yeah, exactly. But coded, right? It's encrypted. And there's expiration date for it. So if I get these credentials right now and I configure my CLI locally, you can do, any of you can do from your machine at home, you can do this action in my account. You can list any buckets in my account just by configuring it. One good thing of assume roles and why they are a good practice, you can revoke sessions real time, right? And any change that you do in any policy, in fact, not only for roles, but any policy that you change for user groups or roles, they reflect in real time as well. So if I change these permissions to deny everything, I won't do it because it will take some time, deny everything and revoke all sessions, I'll drop everybody from doing this command again.
Just one question. Any user are able to list the roles or just the administrator that have access to?
You have to have permissions to list roles. But if you do have this permission, you can use AWS IAM, list roles. Yeah, list roles. You can guess the AWS commands because usually they are intuitive. So this is listing all roles in my account. I could get information from here as well. But I could do it because I have permission to list roles.
Would I use this for example, list a table on my website?
For doing what?
for list a table, for example, for access S3 from my website. For all of users on my website would be able to list, for example, if I have like this token that will permit all my users. Did you get it, my question?
Yeah, I think so. If you come here and say, if I get your AWS accounts of each of you and I include here in the trust relationship, you would also be able to assume role the same way I did. And then you'd be able to call the AWS S3 LS, for example. Is that your question?
Yeah, yeah. Actually, it's like I would think like using, for example, if I have if I have a store online, so I want to list all my products, and my table is like on S3. So I would like to show all my products. This token would be useful to list them for all my users. Or is not the case?
The use case is a little bit strange, but if you want to use objects in S3, let's say images, and you want to make them public, for example, for a website, you can do it.
Yeah. All right.
Yeah, we'll see it in some minutes. That's the next subject. I'd like to jump into it.
Okay.
If you have any other questions, please put in the chat. I'll move forward.
Just one question. So related to this previous question, so I understand that IAM users are more used for administration, like try to manage your service on AWS, right? Or do you use these tokens or user and passwords on your code, for example?
If your code is interacting with AWS, it's using at least one of these entities in somehow, because that's the way we do authentication and authorization in AWS. So there are several ways of doing authentication, as we saw. You can configure the users, you can assume roles. As you did, we have instance profiles in your EC2 instance, for example, that you can attach, and the EC2 instance will be granted permissions. Any of these ways, they are going through IAM somehow. So yeah, I'd say if you interact with AWS, you're using one of these flows. Yeah, I know it's, I think it's the hardest service in AWS because it's tricky to troubleshoot. It's tricky to create good permissions. If you make a mistake, you can make your system vulnerable, your account vulnerable. So it's a good thing to study. Take a look at the FAQ and white paper for IAM. Next service, I'll go for this one quickly. S3, what's S3? It's one of the main services in AWS in terms of object storage. It's not meant to be used as a disk, a block storage. Because of the way objects are organized, there are four main use cases, in fact, for S3, which I described here, which is for storing and distributing images and static content like JavaScript files, HTML, and it's possible to host an entire React application in S3 as a static website. it is static, but the dynamic part of the website is the JavaScript, right? That runs in the customer side. So we say it is static because it's not dynamically running on the backend. These are just files that customers are running on their side. The next one is for hosting static websites related to the previous one, but this time with HTML, JS, and so on. As a data store, so if you're aggregating data, if you want to store logs for further processing, if you have big objects like snapshots, I don't know, VM images, and you don't see it fitting in any other AWS service, you can just use S3 because it allows you to upload up to 5 terabytes for a file, and 5 gigabytes, I think that's it, right? 5 gigabytes at once. Using for reaching the 5 terabytes, you need to use multi-part upload, which is basically splitting your object, your large object, in slices up to 10,000 slices, and up to 5 gigabytes each, up to the limit of 5 terabytes. So you can store pretty big objects there. It has a good high availability, like 11 nines. And there are some pricing models where you can exchange availability per price, per cost, I'd say. So instead of having 11 nines, you want just 99.5% of availability and 99% of durability, and you're gonna pay less for that. And there's a small risk of losing files, for example, or for them not being available when you want to right away. So the main takeaway is it's an object storage. Permissions work the same way using IAM roles. You can upload up to 5 terabyte file, but virtually it doesn't have a limit on S3. So you may have 1,000 5 terabyte files. It's going to be a big bill. And it uses, well, eventual consistency for overwrites, updates, and deletes. So if I delete an object right now, it might happen that if you go half a second later, you would retrieve the object, even if I delete it, because AWS is still synchronizing the change between these availability zones. And it takes a while for overwrite updates and deletes. But actually, I've never seen, I never had a problem with this before. I think when you have a pretty big object, it might, it's more likely to happen. The way objects are stored is pretty simple. There are keys. It's basically a collection of keys. So it seems at the first glance, so let's take a look here, S3. Let me open a bucket, any bucket with more than one object. Okay, there's no hierarchy here, but. So you can see some objects here. So the key for this object, as you can see, is basically the bucket name and the name of the file or any folders that compose this path, right? So if I create a simple object here and I upload it, No, I chose a DMG file, a good one. Any TXT, yeah, Devops Academy logo, that's a good one. It seems like this object here, this zip file and this logo one are in different folders. But in fact, S3 has a flat hierarchy. I'd say it's like a flat file system or something like that. So in fact, you have these keys and they're organized in a way that names that are similar will be grouped together. But you don't really have a hierarchy. So these two files, in fact, they are persisted on the same level. So that's one of the reasons S3 is not suitable for block storage, because it's not really a block storage, but it looks like one, right? About availability, we have all of these classes here. I won't go through them, but as I mentioned, you can see availability might change for some tiers, different storage classes. Holding your data in just one availability zone or 3 or more, and so on. Then you have the minimum size of a file and other restrictions, and the price will change depending on the storage class you're using. So if you take a backup of 5 terabytes monthly, maybe you don't want to store it in this first standard storage class, because it's going to be inexpensive in a way that the business doesn't care much. If the business can afford less availability and less durability, then it's your role as solutions architect or a DevOps engineer to choose the most cost-effective solution, right? So when not to use it, read it later. There are some other services that do stuff that's better, that do specifically what you need. So you don't need to use S3 as a hammer for every nail. And that's it about S3. I don't want to get into many details. But please take a look at the FAQ for S3. There is a bunch of stuff, mainly in these 2 tabs here. Take a look, be curious, check the documentation, static website hosting, probably you need it in the future. You can make your buckets public, all objects public, and just pass a link to anyone to access it. About versioning, you can version your objects. So if someone deletes it, you still have a copy. If someone changes it, you'll have the history. Management, you can set up a life cycle. So recent objects, for example, are in a storage class, which is more high available. Then as the time goes by, it will go to another storage class, so you can save some money. Right, and we have the permissions. Bucket policy is the place where you include your resource-based policy for S3. So here I could say the Dennis Mac user can access these S3 buckets and write objects, but the Dennis user can just read it, for example, just using what we already saw in the IAM policies, right? It's every time you see policy in AWS, it will follow that pattern there, the documentation for permissions. So any question, check permissions. All right. Any question about S3? No? Okay, that's good. So RDS, that's the last topic. Before the break. RDS is a service for relational databases, and it offers a bunch of database management systems. So I'll jump into the RDS console to show you how many DBMS we have here. So we have the open source ones that we already know, like MySQL, Postgres. Then there's Oracle and Microsoft SQL Server and MariaDB. And besides those ones that we know that are in the market for a long time, we have the Amazon Aurora, which is basically either one of two DBMS, database management systems. It will be either MySQL compatible or Postgres compatible. So it's a customization that AWS did for these two management systems, which has a number of benefits. For example, I think it's stated here. Take a look at that. For example, you have 5 times more throughput for MySQL and 3 times more throughput for Postgres just by using Aurora, and it's usually cheaper. So that's a good thing to think about. 6-way replication across availability zones. So not only 3, you'll have 6. Basically, it will get 2 availability zones and include 2 instances each behind the scenes to guarantee more high availability, and up to 15 read replicas and sub 10 milliseconds replica lag. So it's good performance, I'd say. So if you're thinking about using MySQL or Postgres, please consider Aurora. The pricing model is good as well. So going generically here, I'll choose just Aurora for now, but it could be MySQL and database. The idea is you're going to set up a database instance. So it's pretty much the same flow for the ones that have set up a database before. You need to install the software, you need to set up the user, you need to expose it somehow for another backend service to access it, and you need to patch this version from time to time. So for RDS service, AWS is doing some of these things for you, thinking about that shared responsibility model. So you're paying for a service. So you're not creating an EC2 instance, for example, installing Oracle from scratch and setting up users from scratch. Then you have your EBS volume, for example, and you need to snapshot it to back it up in S3. So AWS is abstracting all of this complexity for you on a single service, and it's offering you a way of doing patches easily as well. So if we just go through this setup, you see you need to have a database name and a user and password as usual. You can see here that's not integrated with IAM. So you need to explicitly create a user that I would recommend storing somewhere else. Like I said, for Matt, it could be a parameter store or any other service that you can fetch this value later as a secrets manager. Then you choose the size of this. There are several to choose from, like you need memory optimized instances, burstable, prices will differ, the bandwidth will differ as well. The disks that you're going to have, SSDs, how much size, you can extend it later if needed. About availability, how many availability zones you wanna deploy the solution. It's possible to expand it later as well. This is going to be in a VPC. Same way you create an instance in a VPC. Here you're gonna choose it. You can choose the subnets, and there's one important point here. You can choose if your database is going to be publicly accessible or not. That means that if it's public accessible, AWS will create URL and endpoint for accessing this database publicly. So usually we choose no, but you can change it later. VPC settings, the database port, normal setup. And there's an estimation of costs here with the settings that I just included. So you can see that would be $539 American dollars per month. So if you want to play with this, it's possible. Just come here and choose the free tier. It will choose basic configuration just for you to play with it, get it running, connect from your machine, right? And there's this easy create flow as well that you can create it like with 3 or 4 settings. After this is running, you'll have here your instances. So the size of the instance is here. If it's a writer or a reader, I won't get to the database theory or anything, but you may have several readers to improve performance in your application. So let's say someone from the business side is doing running a report that takes 2 hours to run, and every time it runs, your database suffers. So everybody that's writing to it using your website, they can use it. So how do you solve this? You could create a new reader instance. So there's an option here like create cross-region read replica. And this will create a new endpoint that you can just send to this other application that is doing analytics for fetching the information they need without impacting the writes, which is the important thing. So the same way if you do design and architecture for a database on-prem, you have these options here as tools for you to use, right? But you are not managing the EC2 instance, for example. It's abstracting the storage for you. You can simply, you can test failover, for example. You can do reboot here. You can easily take backups. Sorry. You can take backups, take snapshots from your data easily, or you can schedule them to happen every day, for example, if you need to. So I think that's it, guys. The exercise that we are going to ask you is not that complex. And the project one that Kiko will kick off with you today will have RDS as well. So I'll let Kiko tell you more about it, but it's a real scenario, a simple one, but it's a real migration scenario. So this is going to be good hands-on experience. So you can put in your curriculum as experience because it's a good use case for migration. And you need to touch several services like S3, RDS, and others. I think that's it. Any questions on RDS? Everybody's quiet, so might be a good signal. Or yeah, everybody's good. Feel free to send any questions. Any questions that you need, please send us through. Right?
All good, man. Loud and clear.
Let's do a quick break, 15 minutes, coming back 7:25. Is that all right? Nice, so see you 7:25.
We'll keep the call open if you guys want to chat. Just don't forget to go for a walk and get some water. We'll start in 15 minutes again.
Thank you.
Márcio, Faria there, Anderson, Cristina.
Yeah, I'm here.
Cool. Now, from this class onwards, the course will start getting interesting. Hopefully no one will quit after that.
This is the good stuff.
Yeah, that's the bread and butter from Devops cloud engineer. I'll leave to you, Kiko. 25, so
yep.
Enough break.
Yeah, we can start. It's fine. So yeah, I'm gonna talk a little bit about IAC, which is infrastructure as a code. As Kyle said, this is one of the main tools that we use in our daily work. It's, I don't know, maybe 70% of our work is around this kind of things, especially if you are in a DevOps area, that you are more focused on infrastructure than in a development side of things. And yeah, it's mainly we used to create, manage, and delete and do anything that we need with resource. And because it's as code is in a machine readable structure, normally YAML or JSON most commonly. And basically, instead of like you guys did with all those exercises so far, like creating VPCs and creating subnets and routes and everything, institute through clicks through the console, like Dennis showed, there's an option to do through CLI, and also with infrastructure as code tool, like what we're gonna present here today, right? So before even start with things, how many time you guys spend like creating all that infrastructure with VPC, subnets, and routings and internet gateways and all those things from class 2 exercise? Roughly, how many minutes or hours you guys spend?
Hours.
How many hours? 2, 4, 10?
I reckon about 2.
2 hours, okay. Anyone else want to give a?
It depends. The first time took a while. The first time took a while, but the last 2 or 3 days, I create a net gateway. I create a lot of thinking, like 20 times in less than 1 hour, because I had problems. So I created, I deleted, I created, I deleted. So now it's easier.
Cool. So around 2 hours, maybe some people spend 3 hours, maybe 1 hour. This is my account here. You guys can see I only have the.
I think it's just the first time that you do it.
Takes a little bit more, yeah. For everything we do, right?
Can you guys hear
for
me?
the first time, you spend more time. So yeah, this is
exactly
my account.
You do it now.
Sorry, I cut you, Corinne. You can speak.
Oh, sorry. I think we have some lagging.
You got torrents open?
Yeah. So yeah, this is my account with a single VPC, which is the default. I'm just gonna run this Terraform apply auto-proof, and you guys gonna, let me just put date here. You can compare how long it does it take. So you can see, oops. And I'll go through these comments through the class with you guys there. Yeah, I'm just running init, which is initializing the Terraform for this repository here, this piece of code that I have. I'll go into more details after with you guys about that. And then I'll just start the execution of this code, and you guys can see how faster we can create and change things over Terraform, especially with Terraform, which is one of the main tools that we have here. So basically I'll just go through a few things here. The main benefits around infrastructure as code. The first one is related to the cost, because as you're gonna see, something that took like 2 hours, 30 minutes can pretty much be done in like 2 minutes or 3 minutes once you have the code ready to be deployed. And consider that what you guys created manually was really the basic stuff of a VPC and 2 virtual machines. You could have integrations with other VPCs. You could have like multiple subnets instead of only 4 or 6. You could have other services being deployed like SQS, S3, database like RDS or Dynamo. So it could be a lot of things, and it would take at least 2 hours or 5 hours or even 10 hours, depending on the structure that you need to deploy, right? So one of the things that infrastructure as a code helps is reducing the cost, the time to create things, especially if you need to create environments several times during the week or during the day or during the month. So you can speed up a lot of things. I think my Terraform is already completed, so I'm gonna just run update Terraform deploy the show to proof dash date.
Can you zoom in, Kiko?
Yeah, sure. I'm not sure if I'm gonna be. My control plus is not working. No idea why. I'm using this. Sorry, I only have like files, which is we can see later, but yeah, this is starting to deploy things now. Just leave here, and in 5 minutes you can come back and see. So yeah, cost is one of the main things, as well as speed, which kind of work together with cost, because you're going to be able to provide infrastructure and environments much quicker to the devs, so they can start deploying their applications or testing and doing what they need to do, or even to the customers itself. So it's another thing that helps a lot of the use of any infrastructure as code tool. And the third one would be in terms of risks. Imagine repeating all those steps multiple times. I'm sure that you could click somewhere else or do a different, select a different option, and that could put the entire environment at risk or not working at the list. So having everything as code, you can guarantee that every time that you're running that code, the result will be pretty much the same, and you're gonna have all the research that you need without any kind of issue, right? So that's another benefit from EAC. Cool. In terms of models, there are two main models of infrastructures as code. One of them is the imperative, and the other one is declarative. The easiest way to explain this is imperative is pretty much what you need or what you want, and declarative is how you want, right? So in an example that creating an S3 bucket in an imperative way, you would just say, I want a bucket with that name, and that's it. And in a declarative way, sorry, imperative is the other way around. So imperative, you need to explicitly tell the steps that you're gonna execute. So in order to create S3, I need to go into the console, click here, click on create bucket, define the bucket name, define all other configurations, and click next, 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 and create bucket. So it's you are saying what exactly needs to be done. And in a declarative way, you just declare a state. So I want a bucket created with that name, and the tool will pretty much define the steps that it needs to run or to execute to have the resource that is being defined and applied. So it's two different ways of AAC tools, how they work, and normally we try to focus on declarative ways because you don't need to declare all the steps and things like that, right? As well as models, we also have methods for infrastructures as code, and we have two kinds. One is push and another is pull. Basically, the pull is where you have agents installed on the resources that you're gonna manage. So in the EC2 instance or in a router or in any device. And that device keeps asking for information from a controller, which is in our case Terraform, as an example, because Terraform uses a pull method. Sorry, a push method. But yeah, the resource will keep asking for if there's any updates from the controller to change its state. So let's say that I have a virtual machine that needs to have installed, I don't know, HTTPD server. So the virtual machine will keep asking, I have this installed, is that right? And the controller, if there is any change in the config on the controller, the controller will send this update whenever this request for update is queried, right? And in a push format, pretty much you have a controller or a central tool that will just push all the configurations for the resources, and the controller initiates that communication and that change of structure. So let me just come back here. So yeah, I have, just as an example, I have 14 devices added. If I just come back here into this VPC and reload, we can see that we're gonna have, if my account doesn't expire, yeah, fine. Just give me a second here. Oh, nice. Something changed. So yeah, hopefully I'm gonna have a DevOps Academy VPC. So yeah, I have two, which is good. Yeah, so I have a new VPC here. I'm gonna have all the subnets, the 4 subnets that I created, route tables, pretty much exactly what you guys delivered through the exercise in class 2, all those 11 exercises, not 11 because I didn't create the EC2 instance here, but it's just would be another resource. So yeah, it's as you guys can see, it's pretty fast, pretty easy to deploy. Of course, you have the effort to create the code, which I won't show because one of the exercises that you're gonna have is to create exactly the same thing like here. But I can say it's less than 100 lines of code, pretty much, I guess. So it's not a lot. It's not that hard, and facilitates a lot in the deployment of things. Yeah, so that's about the IC methods, and we're gonna use Terraform, which uses pretty much a push method in a declarative model, right? So we just define what exactly we want, and we push that configuration for the resource, and it just creates. So it's one of the main tools that we have in the market. We have something similar like CloudFormation for AWS, but yeah, Terraform. One of the benefits of Terraform is that it integrates with pretty much all cloud providers like AWS, Azure, GCP. It integrates with other vendors and devices like Cisco, F5, VMware, OpenShift, Kubernetes. So you have an infinite providers, which is things that interact with each of the services, and you can control pretty much resources on anything. There's even people creating Terraform modules to order pizza in Domino's in US. So Terraform can go over IT. It's amazing. And Terraform as a foundation, so it's a very powerful tool. And as you guys go and get some experience, you guys will be able to see how great tool Terraform is. So far so good. Anyone have any questions up to this moment before I jump into more details around Terraform?
Just one question, Kiko.
Yep.
Is Terraform widely used throughout, I guess you could say, the industry, or is there other type of infrastructure of codes that are used also?
I would say that Terraform is very widely spread, as well as CloudFormation from AWS. GCP, I mean, especially talking about cloud environments, but GCP doesn't have a tool to properly deploy things. It has a tool, but I haven't seen anyone using. Azure has something similar to CloudFormation, but again, I think it only works for Azure specifically. So Terraform has a great advantage of being able to interact with multiple cloud providers, multiple devices, multiple vendors. And I think that that's pretty much unique in the market. I don't think there is any other tool with so many options in terms of what kind of resource you're going to manage, updated in a so fast way because it's an open source, and you can create new modules, you can create new providers and interact with anything that you want through an API. Like Danny said, the CLI uses an AWS API, and Terraform uses the same thing. So once the API is available, people just develop code and resources for AWS, Google, Azure, and all those things. So I would say that Terraform is one of the best tools that we have in the market at this stage.
Cool. Is it written in a particular language, or?
I'm not sure. I think it's Go or Python. Maybe Kyle has this answer. I think it's Go, but I'm not 100% sure.
I don't know what is behind the scenes.
Yeah,
I think it's Go.
It's open source. You can just go and see the code, and you're gonna see which language is. I think it's Go, but I'm not 100% sure.
I'll just do a quick Google. Yeah, thanks.
Cool. Yeah. So about any other questions, guys, before I jump in Terraform providers and move on? Cool. So Terraform providers is pretty much a plugin for Terraform, where it has a collection of resources related to a specific, let's say, service. Right? So we have a provider for AWS, we have a provider for GCP, for VMware, and so on and so forth. So a provider is pretty much a collection of libraries and definitions, so you can describe the resources and the code that you want, and the provider will handle this declarative way of those resources being requested, and we'll just create this these resources during the deployment of the Terraform code, right? There are some providers that are provided by Terraform and some others that are provided pretty much by community. I have the two links here. I won't open here. We're going to focus pretty much on AWS in this course, and especially in this material around Terraform. But later, as you guys can see, providers for pretty much anything that you can imagine, and it's impressive, honestly, right? So the provider needs to define in the code, right? So whenever you start creating some Terraform code, like this that we have here, you're gonna define which provider you're gonna use. And you can have multiple providers in the same code. So you can create AWS and GCP and Kubernetes and VMware resources in the same Terraform deployment process. It will depend on how structured you are and what definitions you have in terms of splitting your code, but it's possible to have multiple providers in the same code, right? And each provider has a set of configurations that needs to be done, right? For AWS, the two main configurations is specifying the version, otherwise you just use the latest, and specifying the region. But if you go into the provider documentation, and each provider will have its own documentation, because those configurations will change based on the provider. You can see which options you can have and for each provider, right? So I'm just using the basic one here, which is informing I'm going to use the AWS provider, version, specific version, and in the region, which is Sydney region, right? And after the provider, we can have a resource creation. Like here, I'm creating a AWS VPC. As you guys can see, this just creates what I show you guys. So it's really a small piece of code that you guys probably took more time to click through the AWS console to deploy a VPC than to write a code to deploy things. Once you know the code and you're familiar with the code, it's not that hard to declare and start deploying things with Terraform, right? So it's pretty much defining what's the subnet and what's the name of the resource, which is a AWS VPC with a specific name here that I put, right? So yeah, that's pretty much about providers. I imagine as a plugin that will have a collection of resources and definitions around the service that you want to reach with Terraform. Cool. Jumping to Terraform state, this is one of the key pieces and pretty much the intelligence around how Terraform creates, manage, and delete and interact with resources once it creates. So Terraform is not something that you run and then it doesn't know what created. So Terraform has a memory, and the memory resides in the Terraform state, right? So basically the Terraform state is where you have all the resources related to the configuration that you deploy or the resource that you deploy, and what states those resources are. So any configuration around the resource will be in the Terraform state. So if your VPC is named Devops Academy VPC, that with a specific CIDR, that information will be stored in the Terraform state, right? It's a text file, but it's not recommended to interact directly with this file. It's important to leave Terraform to interact with that, because if you just make a mistake, I wouldn't say it's impossible, but you're going to have a lot of work to restore the previous state and make sure that your configuration in your deployment is correct based on the Terraform state. So it's a very critical file from the Terraform, so be careful with that, right? And also, just like the provider, you need to define the state with this piece of code. You have the options to define the Terraform state locally on your machine. You can define that in an S3 bucket, in a GCS, Google Cloud Storage, Azure, and many other options. Again, the Terraform documentation provides all the information and everything that you need. In that case here, I'm just saying that my Terraform state for a specific piece of code will be stored in this folder here on my local, right? So I'm defining as a local, and this would be my Terraform state file. So yeah, this is a very critical file, and especially when you work in a team, it's not healthy to have this file in your local, because different people will have different states, which can get Terraform to get confused. Then once you create a resource and someone else will deploy the same piece of code using a different state file, your resource will pretty much be deleted. So in those cases, normally we use as the Terraform state backend, or the place where we store the Terraform state, something like S3. So everyone can access the current state and be sure that it's a single version of the state, so everyone has the same thing. And in order to provide some security and to avoid some kind of corruption in Terraform state, every time someone initiates a Terraform deploy, the state file will be locked. So no one else can change or interact with that Terraform state until the action is completed. Being the action a destroy of resources, adding resources, changing resources. So whenever you are interacting with the Terraform state through some deployment, no one else can interact with that file if the file is being shared, right? So even if you do something local, you try to deploy 2 different pieces of code of Terraform using the same state, you won't be able to do it locally because the Terraform state will be in a lock stage. It's very similar to how database works in terms of when something is being updated, a table is being updated, the database management system puts that table in locks, especially if it's a relational database. So it's something very similar, right? Yeah, so this is pretty much about the state. Just keep in mind, try to avoid interacting with this file or deleting this file. If you delete, you probably won't be able to create or interact with the resource that you had previously deployed. So unless you recreate the state manually, which is insanely hard thing to do, and you're gonna take a lot of hours. So try to avoid interacting manually with this file as much as possible. Cool. Any questions with either between provider and the state file of Terraform, guys? Before I move into the Terraform client here.
I have one
Cool,
question.
Cool. Yep.
So are you able to destroy objects or resources the same way as you do with GitHub? Like you can go back to a state, like a previous state?
Well, normally the Terraform code will be managed through something like Git, and with that, you can. So you just something similar as an application and the code that you have in a repository. You just roll back the change or revert the commit, and you're gonna have the previous code. So, and then you deploy again the code, and you remove or update or move to the previous state. So you don't do that through the state file. You just revert the code that you have previously, redeploy the code, and it will fix the things or move to the previous state.
Because I was thinking like, can I use, for example, to create a test environment, and then after I finish with the environment, I just return to the previous state and destroy everything?
Yep, I'm just gonna, so Terraform destroy, this will destroy all those resources that we have there. Terraform destroy. Something exactly as the previous command to deploy things, to apply the configurations. So you can see that you start deleting things. So in like 2-3 minutes, all the resources will be wiped out. So that's why it's a very good use case for development teams, because you might want an environment for some tests for one day. So you create, test, and delete. So you have minimal costs. The efforts to delete things is, as you guys can see, it's effortless, fast. You won't miss a specific resource that, oh, I forgot to create that. So Terraform will just handle everything. And so it's pretty much destroying everything. So if I show subnets, you might don't have, so see, some subnets are already gone. Ordering tables, probably the last was being removed, but internet gateways is probably gone already. So yeah, it's still here, but yeah, it will delete.
Just one more question.
Sure.
So if I use a Terraform code to create the resources, and then I use the web interface to create another resources, if I use the destroy method, it's gonna remove all the resources, even the ones that I've created in the web interface?
No, because Terraform relies on its state, so he only knows the resource that were created through him. So he only will delete the resource that are on the state. So if you create something different through the console, it will remain there. And for example, if you create something like a different subnet in the same VPC that was created through Terraform will probably fail because you won't be able to delete the VPC. So once you start to work with infrastructure as code, you only want to work with infrastructure as code. You try to avoid as much as possible to interact with AWS or any provider through console. Your source of truth for all your environments and all your configs should be in code from now on, let's say this way. And yeah, try to avoid, unless you know exactly what you're doing, that you won't impact things and you know what you need to delete after, try to rely on your infrastructure, on your resource through code. Yeah, so everything was deleted now, so pretty fast, less than 2 minutes, I'd say. Yeah, 52, 54. Yeah, 2 minutes to delete everything. I don't think anyone can delete that fast. Cool. Any other questions before I jump into Terraform client? Sweet. So yeah, Terraform client is pretty much the only command and is a single piece of command that Terraform relies on. So the entire Terraform thing is in a single binary file. You guys create the container with Terraform. You guys saw that it's just a zip file with Terraform binary, and that's it for Terraform. You normally have a bunch of options.
Can I ask you something? Sorry to interrupt you.
No worries.
If I don't want to install Terraform on my computer, what other way can I run the client?
Yeah, you can have a Docker image.
I'm asking for that.
Okay, sorry.
What other way we can run Terraform if I don't want to install the CLI? No answers?
Oh, in a Docker container.
Cool. Yeah, you can just remember that we tried that on the class. We can just run Terraform from the container itself.
Sorry to ruin your question, Kyle. Yeah, in terms of the Terraform client, those are the main commands that we normally use. So Terraform init, and init is pretty much initialization of your Terraform code. They need to pretty much download all the providers that you use and have it locally, at least some information about the providers. We also download the modules, and we're gonna see what modules are in the future. And we'll prepare pretty much the repository for a plan or deploy or apply commands, right? The plan is pretty much you refresh the state and make a delta of what is going to happen if you apply the new code. So pretty much you just show those resources will be deleted, those resources will be added, and those will be changed. So just shows exactly what happens when you run the apply command. And you can during the Terraform plan, you can save the output of the plan. So you can use the output of the plan in the apply. So you can make sure that you're applying exactly what the plan says, because people might be changing things on the way. And the Terraform apply, just as you guys saw, is pretty much applying all the states and the resource as it should be. So just creates the resource, delete resource, and change resource, right? And the destroy pretty much destroy everything that you have in that repository. And each of these commands has a bunch of options. I won't go into much details because of the lack of time, and but you guys can see later a lot on each of those links. And similar to what Kyle, Dennis showed, you can have Terraform apply -- help, and you show. I'm terrible at typing today. And we show all the options that you have for that particular option apply. So everything's very self-documented in the Terraform binary itself. So pretty much all your interaction with Terraform in this open source version is going to be through this Terraform command line. That's why we can use Docker, because it's a single binary, and that's no better thing for Docker than using a single binary for executing things or deploying services, right? Yeah, in terms of Terraform resources, and that's where we define all the things that we want to deploy properly. So all the resources that we're going to create in AWS or in any other place are defined through a resource piece of code, right? This one that we have here is just creating an AWS instance. So an EC2 instance, we have a name, it's defining the AMI, which availability is on, the size, and the name of the instance. Again, each kind of resource have a different kind of configs and settings, and each resource has its own documentation, and you can go through this in the Terraform documentation page, which is in the appendix of this file. And during the exercise, you guys gonna need to go into those documentations and think about this documentation as your best friend to deal with Terraform, right? I'm sure that Kyle and Dennis will share the same thing. I normally don't create any resource without going to the Terraform documentation and see exactly what options I need to provide, what options I want, because it's impossible to know all options for all the resources. It's insanely.
Don't even need to try to remember all of them. Yeah. Easy to just go and check every time that you need.
Yeah, and each resource, so we have the declaration piece of code here. And something that is important to make sure is that each resource has a resource type, which is, for this example, AWS instance, and a resource name, right? So if you want to create a second AWS instance with a similar code, you can use the same name here, right? Because that needs to be unique in your entire Terraform code. You can have multiple AWS instances, but they can have the same name here. Otherwise, Terraform will get confused and pretty much replace the first one with the second one, right? So the name of the resources are normally through the concatenation of those two information. So the name of this resource would be AWS instance.da Academy, right? Yeah, so something, well, I think that I have this here, yeah. About the name, why is it important to have a unique name? Because during the resource definitions and as much as you play with Terraform, you're gonna see that resource depends on the resource, another resource. Like if you think about VPC and subnets, in order to create a subnet, you need to inform which VPC that subnet will be part of. Something similar to here, what I have as an example, the AWS instance in the AWS EAP, which is, you guys, I think, played with this as well. So here we have two resources, but in order to make those two resources together, so attach this EAP into this instance, we have another resource, which is EAP association. And here I have instance ID, and I just say, is it AWS instance.da Academy, which it was, as I mentioned here, the name of this resource. And these will have some arguments, or sorry, some attributes from these resources. So every resource, I won't say every, but most of the resources, once they are created, the resulting attributes. For example, the AWS instance has the ID number of the instance, has names, or has a private IP. So when you create, similar to what you have in AWS console, when you create an AWS instance, an EC2 instance there, you're gonna have the private IP or the public IP, and those things are the attributes of the resource. So you can use those attributes once the resource is created in a different piece of code in the same Terraform code, right? And Terraform, based on those dependencies, because here you're creating a dependency, so you only are able to create this resource once this resource is created, and this resource is created because we are using both IDs of those resources to create this one. And Terraform is smart enough to know that, okay, I need to create these, I need to create these. So for the AWS instance, or in parallel, the AWS instance and the AWS EAP. And then once I have the result for this, which I'm gonna have the ID of this instance and ID of the AP, I can associate those two things. So Terraform will by itself create a dependency and an order of the resource creation process. Most of the case, this is enough. In some cases, you need to specify a dependency, which is a small piece of code like depends on, but it's not very common, or at least for most of our case, Terraform will do it by itself, right? So yeah, the full name of the resource needs to be unique. The attributes which I mentioned, and again, every resource has different kinds of attributes. So an EC2 instance we have, for example, ARN, which is the logical name of the instance for AWS, public IP, private IP, public DNS, and many more. And again, the documentation will have everything. I'll just open a link here, and you guys can see here, for example, I'll just EC2 Terraform AWS EC2 instance. And Google will also make things a lot easier as well to find things if you're lazy to look into this doc as I am. So here you have all the arguments that you can pass for that specific resource, right? Which is AWS EC2 instance. More resources. As I mentioned, it's impossible to know everything like here. So don't try. Block device is just for EC2 instance network, credit, metadata, and attributes. So those are the resulting informations after a resource is created. So ID, ARN, AZ, placement group, and so on and so forth. So this is for a single resource. So imagine that for AWS, and this is just EC2 section, you have all those things here. If you go into, I don't know, ELB, a bunch of other resources. So the list goes on. It's very well documented, easy to follow, but yeah, you need that to create resources with Terraform. It's impossible to create more than 2 resources or 3 resources without coming here. Cool.
It's nice that it shows an example.
Coming back here.
The resource shows an example if you scroll down.
Yeah, I think it's up because it's, yeah, like here. So in this example has the AWS VPC, AWS subnets, AWS network interface, and AWS instance.
It was a bit of delay on your image.
Okay, sorry. You guys can see the screen now properly?
If you can zoom in a little bit, it would be good too.
Yep. Better?
Yep.
Yeah, so because this piece of documentation is about the AWS instance, it has an example of the AWS instance, but also because there are some dependencies here, it mentions those dependencies in the documentation as well. So the only piece to create the instance would be this one. All the other pieces here are different resources, pretty much. But yeah, the documentation normally has good examples that you can follow, unless you go into a very different thing or a very specific requirement, then you're might have some troubles. But yeah, it's pretty useful. Any questions in terms of the resources and how we define options, attributes? Cool. Yeah, this is, it's similar to containers, guys. It's not very easy, and you guys are gonna need to do a few exercises to get used to that, and you guys are gonna see that it's not that complex. It really makes things easier. So like any other language, Terraform also can work with variables. So you can provide informations during the creation of the resource that can change based on your requirements or the environment or things like that. So in this example here, we have a variable named instance type. It's a type of string and has the default value of T1 micro, which is one of the types of instance, EC2 instance that we have in AWS. And you can use this variable during the code, right? So, so in here, in the instance type definition of this resource, we are using this variable here. And for example, for a production environment, you might need different kind of instance or a different kind of AMI or a different region or AZ. So all those configs here can be changed through variables pretty much, right? So you can use variables to create different things for different environments or with different configurations, let's put it this way. Right, so as an example, if you want to create 10 different VPCs with 4 subnets each, you can have the same code and just have input variables for each VPC and subnet, and the remaining of the code will be the same. And you can create those 10 VPCs instead of 2 minutes in 5, 10 minutes. So the input variables can help a bunch when you have different configs for different environments, let's put it this way. And it's not very hard to use as well, right? Just var, which is a specific variable here, and the name of the variable that you defined it. As well as the variables, Terraform can also provide outputs. So whenever you create a resource, if you need some information from that resource or the attribute of that resource, as we see previously, we can have the output piece of code that will have a value of the AWS instance, the name of the resource that we created, and the attribute of that resource, which is private IP. So instead of having to go into the console and see what is the IP address of that load balancer of that EC2 instance or the DNS name of that RDS instance, you can output that attribute in your code, and you're gonna see that output after the code is completed, right? And hopefully we have time so I can show you some of those things, guys. In terms of how we organize the files in the Terraform code, pretty much just like any other programming language, it has its best practices. You can have everything in a single file and it will work because Terraform will look for the entire folder structure or the entire local folder or specific folder. But we normally have this structure, or at least where I've worked so far, had very similar things. So we normally have an underscore provider to define all providers that we're gonna use in that piece of code. Underline backend to define where the state will reside and which kind of state we're gonna use. Variables to define what variables are expected during the execution of the Terraform code. Outputs to declare all the outputs that we have. Then that's something that varies a little bit more. So you have the resource related Terraform file. So you can either have something based on the kind of family of resource that's been created. So you have one file for all your IAM, one file for all database, one file for all S3, and so on and so forth, or you can have just a main file with all the resources. That's not something that is, it has some kind of pattern, I would say. So I would go with family resource because it's easy to find and to structure my files. But feel free to work around this as you like, right? And then we have the TFRs file, which are the variables that are gonna be used during the deployment of the code, right? So all the variables that we define in the variables TF file here, they're gonna need to exist in this anything, which could be development environment TFRs, production environment TFRs. So all the values that you're gonna use for each of these options or those environments would go here, and they're gonna need to match the variables that are defined in the variables file, right? So if you don't have if let's say that you have a variable defined in the variables TF file, like the instance type, and if you don't provide the information that needs to be used here, during the execution, Terraform will just ask for the information. So it's good to have in a file because, again, you have the information as codes. Everything has the same information, so it's easy to not make any kind of issues or create a problem in the environment by having everything in the code. And again, once you run the Terraform apply, you can specify which file with the variables they're going to use for that specific environment. So, and I'll show that here. Cool. So any questions on those last few things, like the variables, outputs, and file organization before we go in and run some codes here, guys?
I have a question. So how does Terraform validate the, for example, variables? If I put the region, Southeast something, but it's all strings. Like, what if I have a typo, and like, how does the Terraform validate the string that I enter all correct?
Terraform doesn't validate the information that you provide as long as it's in the right format that it expects. So it will just fail during the creation. You can have some other tools, I guess, to validate things. But yeah, you won't be able to validate everything unless you have some kind of unit test for Terraform, which I don't see very commonly used. I see some kind of formatting validations, but not to validate that, oh, this region exists in AWS or this subnet exists in your VPC. So you won't be able to make sure that everything is in place before you running at least the Terraform plan command.
Yeah, when you run your Terraform apply, it's going to run because it's a string. It doesn't validate the actual value of the string, but then it's going to fail because that region doesn't exist, and the error will be pretty helpful from AWS, saying pretty much it's going to say like this region doesn't exist, you need to fix that.
Okay, cool. Thank you.
No worries.
I have a question.
Yep.
It's following the same thing that Heaven just asked. For example, if we have a code that we are deploying the code and we have error in the middle of the code, there are transactions, so the code is gonna destroy everything.
Roll back
has been done. Roll back or no?
No, Terraform won't roll back as default. So if I think you have an option to roll back during the Terraform apply commands, but normally it will just fail at that stage and the resource that were already created will remain there. But I think you have the options to roll back, and you can just take a look later. And yeah, probably there's something like roll back here, but not as a default. No, it doesn't have a rollback, I guess. No. So yeah, it will just complete that execution with a fail, and the resource that were created will remain there. So you need to run a Terraform destroy to remove everything that was created before.
But Kiko, but if I apply again, like I get some code which are running and then stop for some issue, if I apply back this code again, they will subscribe the things which I have created before or not?
No, because
I can have some errors because I'm running with the name which already exists.
No, because Terraform will rely on the state file, because the resource that were created successfully, they'll be in their state file. And because the piece of code is exactly the same as before, Terraform will just match, okay, this resource with AWS instance, name it Marcio, I have already deployed. There is no change in the resource. So, okay, the state is already as desired, so I won't touch that. So you just ignore that resource because it's already created.
Yeah, unless if you lose your state file, like you go and delete the state file and run the command, then Terraform is gonna think, oh, I haven't created any, so I'm gonna create everything again. That's the importance of the state file.
And then you have, I'm not sure if you mentioned before, but you have on the command, you can test everything before you apply.
Yeah, you have the Terraform plan, which will pretty much validate the structure. But as I mentioned, let's say that you provided a string, which is expected, but the string doesn't match any proper value. The plan normally won't catch these things because it's not interacting with AWS itself. It's just checking what are the changes that will happen based on the state file and the new code that you have. So you won't be able to see if a value is not accepted by AWS, for example.
Normally the way that we work is you run the Terraform apply, then it's gonna create a few resources and may fail with a few others. Then you go, fix those issues and run plan apply again. And then if you have new issues, you fix that and then run plan apply again until you get a plan and it says you don't need to do any new changes. What you want to be created, it's already there.
I've got one more question.
Sure.
Does Terraform have like an inbuilt like scaling type of ability? For example, if it's like a web server, it's getting hammered and it needs to scale out, create more EC2 instances, for example, or does that rely on the AWS auto scaling group? And do they interact for each other? For example, if we were to destroy that Terraform code as AWS scaled out, would that be in the same kind of destroy command, or would it be totally different?
Now, Terraform won't manage and change things based on what happens in AWS. So because Terraform is a push method, so the information just goes from Terraform to AWS. So Terraform doesn't get information from AWS in terms of, let's say that you have an auto-scaling group and you specify that you want to run 2 instances, but because of scaling, AWS is now running 4. Terraform doesn't know that, and you won't know. So once you deploy the same code, Terraform will just see if anything changed, and will try to revert back. So let's say that you have a security group that you have only port 80 as allowed, right? And you manually change to 443 as well. So once Terraform sees that, it won't make any change because it's not part of what he did or what it did in terms of the security group. So it won't remove anything from there. So that's, again, what happens in AWS, Terraform doesn't bring in. So that's why we mentioned that once you have something, once you start dealing with codes with Terraform, stay there. Try to avoid as much as possible going to the console and make changes, because you're gonna end up in a state that it's not known anymore. So, and one of the benefits of Terraform is that you can see the code and you know exactly what you have there. And if you start making changes manually, you'll lose that that benefit.
All right, cool.
Oh, I have to ask something for everyone. Is everyone happy to go over a few minutes this evening?
Yeah, man. We're all at home.
It's our first time doing that. We still don't know how to manage our time, and the stand-up was a little bit overtime as well. It's just that after Kiko finishing the class, we still have one last thing to talk with you guys, so it's gonna go a bit over time. Sorry.
Yeah, I think more 5 or 10 minutes we can complete this part, guys. So try to be quick here without losing the content. So yeah, let's run some code here. I won't jump into the module thing here, but you guys can run into that later, but I think this part here is nice. So I have a piece of code in the repository. If you guys just pull, you're gonna have the same thing, and it's open here in my Visual Studio Code. And this is pretty much Terraform code with a Terraform backend using local and Terraform states. I'm using a provider here, which is, yes?
Zoom in, please.
I think this will work. Better?
Thank you.
Sorry, I use a high resolution here, guys. Yeah, so the backend, which is local, and this is the path to the backend, which is the Terraform states. The provider I'm using AWS, same thing as you guys saw there. S3 here, I'm creating a resource of the kind AWS S3 bucket, name it bucket. The name of the bucket itself is going to be based on a variable that I'm passing through this class TFVars, I can show you later, and a random string. And this is a kind of resource from Terraform, because in some cases you need to have a random string in the name of a resource, like RDS is normally use that, buckets and things like that, because once you start to create more times the same code, this will make sure that you are not trying to create a resource that already exists in AWS, right? I have also a security group here, which is just a security group, name it test.sg, has an ingress of port 443 for this subnet here, and just the name test.sg here. The class TFR, so first the variables here, I'm defining a variable named bucket name, which is the type of string, and I'm saying that this class TFRs, I'm going to use Devops Academy as the variable to be used, right? So that's a simple piece of code of Terraform just to create a bucket and a security group, pretty much. I'll just copy here, just make it easy and to avoid typos. I'll just, you failed me to Terraform.
You guys have noticed on the security group, the inbound was called ingress. That's another way that we call it. Sometimes will be referenced as ingress instead of inbound, but it's the same thing. And for outbound, it's egress.
Yep, would be like this, egress. Yeah, and Terraform only accepts ingress instead of inbound. So for Terraform, you guys need to use that format here. We're just downloading the plugins, which is the providers, random, and AWS. Yeah, I should have done that before, but sorry about that. You see that the .terraform was already created. The TF file here, you guys can see it's JSON format, but don't touch the plugins, which is random, and AWS should be here soon. Which is a binary, so we won't be able to see. Sorry. Click. Let me see if it's still downloading. Yeah, it's there, so it should complete. Cool. And yeah, then just paste. So what I'm doing here is just Terraform plan and that file as input variables for the variable are the code, right? So the plan just show exactly what Terraform will apply based on what it has in the state, which is pretty much empty, to what we are defining the code now, which is pretty much you will create the two resource or the three resource, because we have the random ones. Oh, sorry. So the buckets, the security group, and the random string, right? So instead of plan, we can just run apply here. Terraform apply. And we just apply those configs that are here, right? So you won't create a string So yes, I didn't set the auto approve here, so we just ask for confirmation. It shows the same changes that we had in the plan, so it's fine. It's creating, as you guys are gonna see, it's pretty much quick. So 7 seconds to create a security group and 17 seconds to create the S3 bucket, right? So if you go into the AWS, you're gonna see the bucket there. It should be Devops Academy with some random string after that. Not very fast, sorry guys. So yeah, Devops Academy and this random string here was created, right? So cool, so easy to create those two resources. Now let's make some changes here, both in the S3 file and first in the S secret group here. So if we change here to 80 instead of 443, 80, so it's saved. And for the S3, let's just gonna change the var here. Devops, instead of Devops Academy, let's put DA. DA. Okay, so if I run the Terraform apply or even the Terraform plan, what do you guys think will happen? So anyone wanna guess?
Probably you will show the same thing for you because the variable is correct, the structure of the file is correct.
What will be the change?
What will happen with the existing resources? Yeah. What will happen with the resource that we have there?
I guess gonna happen enough for the one that you have there, and it's gonna create a new one.
You would delete what you have and create a new one?
Nah, I don't think it'll delete it.
No, it's gonna happen anything for the one that you have there.
Both of them?
Yeah, it's gonna create a new one because you changed the S3 name.
Both of them? Also the same for the security group?
Yeah, you have more items. So.
For the security group, there you will just add this string.
So we did changing the S3. I don't know. I'm asking if you guys. I'll just run the plan here. Yeah, I mean it's you guys gonna see something that is nice here because what will happen will depend on the change that you're doing and which resource you are making change, right? So, and Terraform plan will show exactly what will happen, but basically the secure group will be changed. So we have here plan. So one will be added, one will change, and one will be destroyed, right? So if we see here, and Terraform has a good visualization here. So the S3 bucket will be replaced. So it's going to delete the existing one and create a new one. Exactly because you can change the S3 bucket name, right? If you were changing, for example, something different in the bucket, like changing versioning, enabling versioning, for example, here, it wouldn't be replacing, we just update. For security group, it will update in place. So the security group will remain there with the same name, same ERN. So it won't be deleted, but it will change the following things. So the ingress, it will remove this block here, which is removing the 443 configuration. And we will add this configuration here, which is pretty much what we did, just change to 480, right? And we also have, that's pretty much it. So if you run the apply here, you guys gonna see the bucket being deleted, the bucket being created through those methods that we're gonna have here, right? So, and that's important for you to see exactly what you're doing because you might change something in a database and the database is being used. So the database might be replaced. So consider that replacement will put your environment down. So the database won't be available for some time. So once you plan and apply change, you need to be careful of what will happen. So you minimize the downtime of your environment. At least if you know there's going to be downtime, let people know that you're going to cause some interruption on the services and things like that. So yeah, the destruction of the bucket happens in 5 seconds. The modification in the secure group happened in 1 second, and it's just now creating the again.
That's a good information to know. It's quite fast to create a new environment, but it's quite fast to destroy everything with a wrong click.
Yep.
Question?
Yeah.
Where is the connection, for example, with the old Terraform file with the new one? Because the S3 name was different. How did it understand that they are the same S3 bucket?
Because of this thing. So the name of the resource aws3.bucket is the same. So if we create a different resource here with a different name, like AWS S3 bucket and bucket 2, then it would consider a different resource. But because we made the change in an existing resource in the Terraform state file, it will show that AWS bucket of type and name here. So it has all those configs about the bucket as we mentioned. So this is where Terraform knows everything about the infrastructure or the resource that are there. So that's why you need to be careful deleting this, because if Terraform doesn't have those values, you will think that it needs to create everything again, and you'll fail because resources are already there with that name. But that's how Terraform knew that it was changing an existing resource, because the resource name was exactly the same, AWS S3 bucket.
Okay, thank you.
Any other questions, guys? I won't jump into the module things here. I'll leave it for you guys. It was an extra. It's just, you guys can read through that. There's an exercise you guys gonna be able to do some things, and reach out if you need any help on this specifically or any other exercise. Also, there are some nice links here about the Terraform modules, Terraform expressions. We didn't cover, but you can have loops, you can have ifs and else's inside Terraform, which is advanced things, but you guys can take a look. And some other infrastructure as code tools like CloudFormation, Ansible, Puppet, and Chef, which are the most common ones, but again, there are a few others. Any questions, guys, before we jump into the final things for the class today?
Your connection is really struggling, man.
Sorry about that.
Yeah, you guys will see that most of the exercise for, not most, but I think a few of the exercise for this class that Kiko created, pretty much to redo whatever you guys have done in the past. Just now everything as code. It would be quite nice to understand what is the difference. Any other question for Kiko's class? So let's move on for the last part of the class. If you guys, as you know, if you have any questions, reach out to us. We're here to help anytime that you guys need. One last thing that we want to discuss today is about the first project of the DevOps Academy course. So Kiko is going to go into details of that, what we expect you to do. It's going to be a group exercise. So we have split you guys in 3 groups. And for each one of the groups, one of us will be kind of a project manager or a product owner of what we are trying to achieve. So if you guys need any help, you reach out to one of us specific for your group. Yeah, the project is supposed to be delivered in 2 classes, I think. So you have 4 weeks to do it. And then on the next, on the delivery of this project, we are going to give the final project, the second and final project to be delivered in the last, on the last class. So I'll leave to Kiko to jump into the description and tell you guys what you need to do and about the groups as well, so we can finish the class.
Yep. Hope you guys can see the screen and listen properly. So yes, Kyle mentioned we're gonna split you guys into 3 groups of 4 people each. We're gonna send the groups that we format later. I won't send here. I'll just try to focus on the project itself, and we can try to take some questions and things like that here, and then I'll send the groups after the class for you guys. So basically, this is a very work-related project. So it's very similar to what we do in a few of our engagements with customers. So it's a very good experience for you guys to have and work through that kind of requirements and challenges. So it's going to be hopefully a good learning experience for you guys. So in this first project, we're going to have, imagine that we have an application running in a LAMP stack, which is a Linux, Apache, MySQL, and PHP configuration. It's a WordPress application, a web application running PHP. We have a MySQL where we have the database. We have the PHP files from WordPress, and it's pretty much a web browser accessing this service, right? So what we're gonna need to do in this project is pretty much move this infrastructure to AWS with those requirements that are listed here. So basically, we're gonna use containers, Docker containers, to run the application side, so the WordPress part of the solution. The application needs to be secure, so we expect to have the data encrypted at rest in transit. Some kind of high availability for the solution as well. It needs to have some scalability. That's an example of that 10 times the average, but I think that the environment needs to grow and shrink as demand. We need to have all the deployment through code, so using Terraform specifically, and some kind of fast way of doing some interactions with the code and the application. So pretty much some CI/CD practice, which will be covered in the next class in 2 weeks. So you guys can leave that part for next week to start on. All the remaining pieces of these, you guys already have the knowledge, had the exercise, and can go to that. And again, any questions, any concerns, anything that is struggling, just reach out and we can help out as much as we can, and as we did in the during the exercise with you guys, right? What you guys gonna need to deliver by group is much presentation and demonstration of the solution, and 10 minutes with the 3 of us asking questions and pretty much understanding what you guys did, how you guys did, and the reasons why you did the things you guys did, right? One of the assumptions is that it's just an example, so we won't be migrating data into this new project. So consider that the database can be empty, or at least you guys can create some volume of data there after the environment is created. It would be good to have some kind of tests in your pipeline, even that you don't have the test being executed. Just consider this step in the pipeline. And again, pipeline is a subject for next class. You guys are gonna understand a little bit more of that next in a couple of weeks. Consider the application as stateless as possible for this pilot. So again, this is one of the challenges that you guys are gonna have. Yeah, and we're gonna use a single GitHub repo. So we're gonna create the structure. I think the structure is already there, but we can create the groups segregation in this project section of the repository. And for each group, we have a specific either repo, or we can do in the same repo. We can see how we're gonna do that, right? There is some information about the grading. It's not pass or no pass. It's just so you guys can have a feedback about that. The kickoff, which is happening today, consider that the project introduction will be done. The teams is going to be provider. We're going to create channels. We can create the Git repo. I think we're going to create each repo for each group, I guess. Yeah. And we're also going to have a GitHub project, so we can work in a way similar to Agile. So as we had in the Agile class, we're going to have a board. We're going to have the tickets, the tasks on the board. So each person can pick a task and move that task across the board as normally would happen in a work environment, right? So in an Agile model of work. There are some resources here that you guys can use. Some very interesting, especially about how to set up WordPress best practices in AWS. So use that. Some technologies that we are suggesting should be used. You guys can pick different technologies, but we suggest you use those. Here we're just gonna update probably to GitHub Actions as well, because it's what we're gonna handle in the next class. But all the other things are things that are covered pretty much during the whole course so far, right? And here we have the timeline. So you guys can follow these, create your own timelines. The most important thing is to break down the stories and plan the work as soon as possible. So you guys can start working on each ticket, let's say this way, and get the presentation, everything working ready in week 4, which is class 6.
Yeah, we'll heavily suggest you guys to get organized, like starting from tomorrow. Karini just asked about the tool. We suggest you to use GitHub projects. Dennis just replied to you as well. You can set up a board there, and it's easy, it's simple. It's all in the same repository. I think we are gonna request you guys to create us external GitHub project, GitHub repository for each of the projects, so you guys can create some CI/CD pipelines for your project. So we don't need to give any external permission on the DevOps Academy one. Then we can just link your work to our repository once it's done. So I'm gonna split you guys on the groups. Suggest you to get together. We'll create some Slack channels so you guys can talk with each other. It won't be private group channels, so it's free to look around. And then organize the board, try to get a Zoom call between you guys to see what needs to be done, create tickets for that, and then just start assigning and start working on. Don't leave for the last minute. You guys know that even the exercises are hard to get all done for the classes, and now you guys have even more things to do. Cool. Let's do the groups. So the first group is Lucas, Luis, Cristina, and Marcio Anatriello. Cool. We are gonna create the Slack channel and add you guys to there. And we actually didn't split between ourselves which one of us will be for each group. So hold onto that until tomorrow morning. And second group is
can you repeat one more time?
So I told you guys that each one of us will be responsible for one of the groups, but we actually haven't split ourselves yet, because we just decided on the groups like just before the class. So, but just wait until tomorrow morning. We'll send that through for you guys.
We'll send out this information in Slack as well, so don't worry too much.
So the second group is Marcio Faria, Matt, Denise, and Adriana. And the third group is Anderson and Henrique, which we don't Have anyone heard about Enrique this evening? We don't know what happened. Heaven and Karini. Cool. Anyone have any questions about the project, about the class? Feel free to reach out to us, send a message.
Well,
you guys want to do
one comment?
Some Zoom calls during the week. We are here to help you guys.
Just one comment, Kyle. There are fewer exercises to complete this class. So, because besides that, you have the project one now. I think that should be the main focus because it brings all together. So you're really migrating an application, containerizing. You're going to do it in a pipeline. You're using AWS services. So it's a good opportunity to bring all together, to put in your portfolio. So just decide where this GitHub repo will be. It can be in any of your accounts. And remember to share this link with us after you create this repo. And please let us know if that's too much, too many tasks. We are happy to schedule one-on-ones if needed, or even better with groups. You can schedule meetings, weekly meetings, because we'll have like 4 weeks to complete this. I think it's good to have a checkpoint or something like that. Yeah.
Anything else? Nothing?
Yeah, any question about the project? If you guys have.
I have a question about
so far so good.
It's being recorded. It will be released for us to watch again. Just like few stuff that Kiko was talking, I couldn't hear properly in the beginning because I had just my normal speakers.
Yeah, I'll see if this recording is good.
Yeah.
And then I'll upload it. As soon as I upload it, I can share the link with you.
Yeah, you can just go just upload to S3 and then we can download and then delete. Whatever.
Yeah. Okay, that's good. That's good. I was thinking more like a YouTube or something, but
you want to share with the world, that's fine.
S3 will do.
Yeah, I just need the file to just rewatch it, like few little stuff.
Okay, good.
No one has anything else to say? We just finished the class. Thank you guys for your company again. Yeah.
No.
Thank you very much.
When you guys will define that group properly, like which I can get the names and see what I work with, who I work with.
I'm just sending that through in 2 minutes.
Cool.
Hey, Kiko, after class, do you mind if I can go through some of my submissions with you for class 4?
No, all good, man. Cool.
Nice. So for everybody else, have a good night. Thank you. For
have a good night, guys. Thank you. All right. Thank you. Bye.
Caio, can I schedule the time with you tomorrow?
Yes, please. Send me a message.